And we're back. This is part 2 of my video on factoring trinomials with a leading coefficient other than 1. We are looking at trinomials and factoring them using both methods that we've learned in the book this week. Let's take a look at this one. Now, remember that even before you think about grouping or trial and error or anything else, there's the underlying possibility that a polynomial might simply have a common factor that could be factored out. Notice that in this trinomial here, all of the coefficients are even, which means they're divisible by 2. They have 2 as a common factor. You could factor out a 2. Now also, it's completely awkward to try to factor a trinomial where the leading coefficient is negative. When that happens, what I recommend is that you factor out a negative when you factor out the common factor. So what I would do to start here is I would say, let's factor out a negative 2 and ask ourselves, as we think backwards through the distributive law, negative 2 times what would give me negative 12c squared? I'd need a 6 and a c squared. Negative 2 times what would give me negative 38, or another way to say that is, what is negative 38 divided by negative 2? And that turns out to be 19, so 19c. And similarly, 22 divided by negative 2 is negative 11. So I factor out the negative 2, but I have to pay attention to the fact that the trinomial that's left could very well, probably will, factor some more. And therefore, we're going to use our 2 methods to factor that. We're going to use grouping, first of all. Now, remember that we're looking at the partially factored trinomial, so this is where we are looking. This is my first coefficient. This is my second coefficient. 6 times negative 11 equals negative 66. And I'm looking for 2 numbers that multiply to give me negative 66, but add to give me 19. That's this right here. So we think about the factors of negative 66. Again, if you just think of some that you could use, go right ahead. We're looking at the sum of the factors, hoping to get 19. As you practice this a little bit, you might realize that you can eliminate some kind of out of hand, and that might save you some time. The fact that we are aiming for a negative 66 means I've got to pick a positive number and a negative number. The sum that I'm aiming for, though, is positive, so I think I want to choose this so that the positive number is the one that's larger in absolute value, and the negative number is the one that's smaller. So negative 1 times 66 would be an obvious first choice. But if you look at that and see in your head, negative 1 plus 66 is not going to be anywhere near 19, and you want to skip that, that's fine. You might feel comfortable doing that, and maybe try 2. You'd want to look at negative 2, and that would give me negative 2 and 33, and that's still pretty far off when you add them up, so, just kind of skip over that. Be more methodical if you need to, but if you can just visually eliminate an option, that is absolutely fine. So then you might say, well, what about negative 3? Does negative 3 divide into negative 66? Sure, it's 22. And guess what? Wow, that's it. Negative 3 plus 22 is 19. So when I factor by grouping, I will split the middle term using these 2 coefficients. Now I want to be very, very careful. It's easy to say, oh, I'll remember the 2. I'll remember to put it back later. But I always forget. So I'm going to leave the negative 2 times the parentheses, 6c squared, split up the middle term using the 2 coefficients you've come up with, negative 3 and positive 22, and then finally at the end of negative 11. Factor by grouping. So if we group these 2, I see that there's a common factor of a 3 and a c. Now, the parentheses are going to get a little ugly here for a minute. I'm going to make these just a little bit bigger so it's clear that we're going to have parentheses inside parentheses. Factoring out the 3c, I'd be left with, from what I have in the gold there, 2c minus 1. Do I see anything in common in the second group? Yes, those are both divisible by 11. I can factor out an 11, and that would leave me with 2c minus 1. Perfect. Big parentheses on the end to sort of delineate that. In here, I do have a common binomial factor, which I can factor out from what is in the big parentheses. I would still have the negative 2 from up front. I'm factoring out the 2c minus 1, and then I would be left with 3c plus 11. And that's the factorization. Now, same problem using trial and error. Some things are the same. You always look for that common factor first, so we would still want to factor out the negative 2 and get 6c squared minus 19c plus 19c minus 11, just like last time. But this time we will begin using our trick of trial and error. I'll just remember that the negative 2 is here, and if this is going to factor at all, it'll have to be something c plus something, something c plus something. These two numbers have to multiply to give me the first coefficient, so a product of 6. These two numbers have to give me a product of negative 11. Now, really clearly, there's only one way to factor 11 and 1. So why don't we go ahead and put those numbers in first. One of them has to be positive, one has to be negative. It's not quite as certain which one is which. Let's put a positive 11 and a negative 1, though, just to start. And then you think about, well, how could I get a 6? Well, there's several ways to factor 6. It could be 6 and 1. It could be 2 and 3. We can try either one to begin with. You can be methodical or you can just jump right in. I'm going to try to use a 2 and a 3. And then I'm going to check the OI to see if I get the proper middle term. Outer product, negative 2c. Inner product, 33c, gives me 31c. And I was hoping for 19c. So that's not what I wanted. Remember that one of the options you always have is to use the same numbers, the same coefficients, but just change the order around. I'm going to do that. And I think I'll keep, this still has to be a product of 6. This has to be a product of negative 11. So I'm going to keep this as a 2 and a 3. But I'm just going to reverse the two numbers and put negative 1 here and positive 11 there. And see if that does any good. Let us check the OI. Product of the outer terms, product of the inner terms. The outer product is 22c. The inner product is negative 3c. That gives me the 19c that I was hoping for. So I have found the factorization. I would just rewrite it cleaner. I don't want all these arrows and check marks and underlines and all these kinds of things, but just writing it a little bit cleaner, I would say negative 2, 2c, instead of plus negative 1, say 2c minus 1, and 3c plus 11. And lo and behold, that is the same answer we got by grouping. Both methods work great. So as you look at this and try some of problems in the homework, I'd recommend trying some by grouping and some by trial and error and see which one works best for you. I do have a small opinion. What I've encountered, for the most part, is that students tend to get the grouping method first because it's a little bit more methodical, a little bit less casting about in the air. But the problem with that is that it's hard to get much faster in that method. Now, you may find this hard to believe, but the trial and error method, students tend to get some instinct after a while of what numbers make good choices to put in which blanks, and can do the checking of the OI, which is kind of your checking step, almost in your head. So over time, many students get faster at, they can do both accurately, but they can do the trial and error faster over time. That's particularly important if you're going to be using a lot of mathematics, if you're going on to trigonometry and pre-calculus and calculus, maybe heading for a science or technology or engineering or math major. The speed becomes important. So for right now, just try and see what works for you. Do a lot of good practice. See which one works for you. And just see if after a few examples you find yourself getting faster at one method or the other. Best of wishes.